Welcome to Water Mission's video series on the Grundfos Renewable Solar Inverter, or RSI. This video covers how to determine and set the correct pump rotation direction for a submersible pump. Topics include why having correct pump rotation direction is important, how to determine the correct rotation direction, how to set the rotation direction with the RSI control keypad, and how to change the pump rotation direction through physical wiring. First, let's discuss why having the correct pump rotation direction is important. Having the wrong pump rotation direction increases the risk of mechanical stress and wear on the pump as well as cavitation. Both of these issues can cause internal pump damage, which may shorten the lifespan or lead to pump failure. An incorrect rotation direction will also lead to decreased production, pressure, and efficiency. Not only does having the pump rotating the right direction help protect the pump, but it enables the pump to perform as expected at the project conditions. Determining the proper rotation direction is especially important for submersible pumps, since the pump is not typically visible during operation like with many surface pumps. So the proper direction must be determined based on performance rather than simply looking at the pump itself. Next, we will discuss how to determine the correct rotation direction for your pump. This video assumes that you have already completed the Startup Wizard and have accessed the advanced menu. If you have not completed these steps, check out Water Mission's other videos on these topics and complete them first. Also, check the pump curve for your specific pump and Water Mission's pump design tool to get an idea of the expected operational pressure, flow, and current draw. Start your pump with the RSI by pressing the on button, and your pump should ramp up to its maximum rated frequency. If this is a new project, this may be your first time starting the pump. Make sure to check for leaks or other issues that need to be addressed. Check the operating pressure at the pressure gauge closest to the pump. For borehole projects, this should be at the borehole location. This pressure reading should be within the pump curve pressure range. In our example, we are reading about 16 psi. To determine flow rate, do a 30-second water meter test. The easiest way to do this is to take a 30-second video of the water meter and then go back to see the beginning and end readings on the water meter. If you do not have a way to record a video, then carefully note the water meter readings at 0 seconds and at 30 seconds. With either method, subtract to get your 30-second volume, which for our example is 59 liters per 30 seconds. Multiply this by 2 to get the 1 minute volume, which in this case is 118 liters per minute. Then convert this to cubic meters per hour, which for our example is 7.08 cubic meters per hour. Take a picture or a short video of the multi-monitor to see the motor current draw at the frequency, which in this case is 15.65 amps. It should be noted that your multi-monitor may look different and can be adjusted to include these parameters if needed. Check out Water Mission's instructional video on the multi-monitor to learn how to do this. When gathering the required information, it is recommended to take the videos and pictures all at once and then turn off the pump to do the math and performance checks in order to limit the time that the pump may be operating in the wrong direction. When we got to this project, the pump was operating in the reverse direction. It should not be assumed that this is wrong, as there are many opportunities during the installation for phases to get reversed, and maybe it was set in the reverse setting on purpose. According to the pump curve, however, the pressure and flow from the initial 30-second tests are significantly lower than expected, pointing to the likelihood that the pump is rotating in the wrong direction. While there are many potential reasons for this, if the numbers are significantly different than expected, change the pump direction and repeat the 30-second water meter test to see if the performance improves. To do this, note the direction of rotation on the control keypad, press Home, Main Menu, Quick Setup, scroll up and select Rotation Direction, Edit, and change to Forward. Press OK to save, then press Home and select Multi-Monitor to return to the multi-monitor. Turn the pump back on and record the same information once the pump has reached its maximum frequency. Check the pressure gauge. We are now operating at 80 psi. Repeat the 30-second water meter test. Again, we recommend recording a video on your phone to reference for a more accurate reading. Repeat the same math from earlier to get meters cubed per hour. Rotating in this direction, we read 12.36 meters cubed per hour. And then the current draw is 13.5 amps. Comparing the two tests, pressure and flow in the forward direction were much closer to the pump curve than the reverse direction. While current draw was actually closer at first glance in the reverse direction, the behavior is consistent with incorrect rotation because it's pulling more amps at a lower flow and pressure than the forward direction. Based on these tests, the forward direction is the correct direction even though the number deviates a bit from the pump curve. There are many potential causes of deviations from the pump curve, and the goal is to think about it holistically for the project. It could also be a combination of factors. Likely causes could include: the pressure gauge is typically a distance away from the pump versus the pump curve, which is at the pump, since the pump is typically deep in the earth inside the borehole. So for this project, the actual PSI at the pump is likely 5 to 10 PSI higher than the gauge is reading. The flow meter installation may not be installed according to the specifications with required length of straight pipe before and after, which could lead to slightly inaccurate readings. As we see here, there are leaks in the system, which adds to the pressure loss. Grundfos pump curves have a rated accuracy of plus or minus 10%, so the differences may not be as large as recorded in the test. When we arrived at the project, the pump had been operating in the reverse direction. Through this test, we discovered it should be running in the forward direction, so potential pump wear from operating in the wrong direction could decrease performance. Next, consider the design. This project was not designed using the Water Mission pump design tool, and the pump was selected based on availability rather than the system curve, so it is not operating as efficiently as it could be. Finally, this is not the case for this example since we had full power available during the tests, but at solar-only project sites, the availability of power could influence the tests as well. For instance, if the solar was not functioning properly or if it was a cloudy day. Make sure to check out Water Mission's other video on important performance checks after the initial RSI programming. Let's take a closer look at setting the proper pump direction. There are two primary options for how to do this. Water Mission always recommends using the programming option with the RSI as it is safer and faster. In this example, we started off in the reverse direction and we needed the pump to be in the forward direction. We quickly showed this earlier, but here's another look at it. Make a note of which direction the arrow on the multi-monitor is pointing, clockwise or counterclockwise. Press Home, Main Menu, Quick Setup, scroll up and select Rotation Direction, Edit, change it to whichever direction you have determined is correct. Press OK to save, ensure that the arrow has reverse directions, press Home, select Multi-Monitor, and then reconfirm that the arrow is still facing the direction you selected. The other option for changing the pump rotation direction, which can be done with any three-phase motor, is through physical wiring. Do not proceed with this step if you are not confident in electrical operation and safety. Only perform these steps if you are a qualified individual, as lethal voltages or arc flash hazards can be present within the RSI. See Water Mission's video on initial troubleshooting steps for more information on safely interacting with the RSI. If you are qualified and have decided to proceed, make sure you are wearing appropriate personal protective equipment. Properly disconnect all power sources. Apply lockout tagout. Wait 5 minutes before opening the RSI, and then check with a multimeter to ensure no dangerous voltage is present. After opening the RSI, switch any two of the leads going to the pump. This will reverse the rotation direction. This approach is more common with motors not controlled by a VFD, and as you can see, it takes longer and introduces a source of danger. So switching the direction through programming the RSI is always preferred. Thanks for watching this video on determining and setting the proper pump rotation direction with the RSI. Make sure to check out Water Mission's other Grundfos RSI training videos.